Hello, everyone. I am Ember Quartz, digital persona at Kadel Labs. Welcome to our session on performance engineering. Today, we'll explore how to achieve optimal application performance using our layered performance engineering framework. We'll cover 6 key areas important for performance optimization. By the end of this session, you'll understand the best practices and tools identify symptoms and root causes in each layer of the application. Let's begin. Layered analysis involves dissecting an application into its various components, such as the user interface, application logic, middleware, database, infrastructure, and network. With this approach, we can isolate bottlenecks, which enables targeted and quantifiable optimization. Let's deep dive into each layer. Let's focus on the application's user interface. Poor performance at this level can lead to slow page load times, unresponsive interfaces, and a high time to interactive. Beyond just speed, unoptimized visual elements can cause issues like flickering animations or delayed content rendering. Excessive JavaScript execution and inconsistent performance across different browsers can exacerbate these problems. To diagnose these issues, we rely on front-end profiling, using browser developer tools to measure load times, script execution, and rendering performance. Additionally, user experience testing helps us understand how real users interact with the interface, while synthetic transactions, conducted through non-intrusive tests, allow us to monitor performance from various locations and under different conditions. We categorize our toolsets into 3 main areas. First, for web performance analysis, we use tools like Lighthouse, Google PageSpeed Insights, and Web Page Test. These tools help us measure and improve page load times, accessibility, and overall performance. Complementary tools like GTmetrix and Yslow provide a more detailed performance grading and offer optimization recommendations. For user experience and performance monitoring, advanced solutions like Dynatrace, New Relic Browser, and Pingdom allow us to track real-time user interactions and performance metrics. Tools like Raygun and Datadog Rum provide additional insights into user experience, helping us identify potential performance bottlenecks in real-world scenarios. Now, let's take a closer look at the application layer. These include high latency in processing requests and timeouts during API calls or database queries. Excessive CPU or memory usage is another key indicator. Frequent application crashes, slow execution of business logic are additional indicators. Long response times for dynamic content generation and memory leaks are further issues that cause performance to degrade over time. To diagnose, we rely on a range of tools and techniques. Load testing plays a critical role in this process. By simulating user traffic with tools like Apache JMeter, Gatling, we can observe how the application handles varying loads. Combined with monitoring tools, load testing allows us to see exactly how the backend code behaves under load. Application performance monitoring or APM tools like New Relic, AppDynamics, and Dynatrace provide real-time insights into application health, helping us identify latency issues and resource bottlenecks. Profiling tools, such as Visual VM or JProfiler, allow us to dig deep into the code, pinpointing where excessive CPU or memory consumption occurs. Database query analysis tools help optimize slow or inefficient queries that can impact performance at the database level. In managed environments like Java or .NET, heap dump and garbage collection analysis play a vital role. Using tools like Visual VM or EclipseMat, we analyze heap dumps to detect memory leaks and inefficient memory usage, which can lead to performance degradation over time. Monitoring garbage collection activities also helps us ensure that memory is managed efficiently. In summary, by leveraging the right combination of load testing and monitoring tools, enables us to pinpoint the root causes of application performance degradation over time. Now, let's shift our focus to middleware. Middleware performance problems can appear in different forms, such as delays in messaging queues, failed message deliveries, or increased memory and CPU usage. Other signs include delays in asynchronous processing and high error rates during message transformations, which may indicate issues with the conversion processes within the middleware. Latency in API gateways or service buses can slow down the entire application, while inconsistent message delivery order can lead to data processing errors and inconsistencies. To accurately diagnose these issues, we rely on a combination of monitoring, log analysis, and resource tracking. Real-time monitoring tools such as IBM MQ Explorer, RabbitMQ Management, and Apache Kafka Monitoring allow us to keep a close watch on message queues and processing rates, helping us identify bottlenecks as they occur. Log analysis is another essential technique. By using tools like the Elk Stack or Splunk, we can dive deep into middleware logs to uncover errors, failed deliveries, or unusual delays. Monitoring and API logging have become critical in today's API-driven landscape. Tools like Prometheus, AWS API Gateway Monitoring, and Azure API Management help ensure that our middleware is functioning optimally. Additionally, a thorough review of middleware configurations often reveals opportunities for improvement. Finally, we focus on load balancing and failover strategies to ensure that the system can handle traffic spikes and recover quickly from any failures. Now let's look at database, which is at the core. Let's begin by identifying the key symptoms that could signal potential database performance problems. Slow query response times are often the first indicator. When queries take longer than expected, it can slow down your entire application. High I/O wait times are another critical issue, as excessive waiting on disk operations can create bottlenecks, stalling your system. Deadlocks and contention issues arise when multiple processes compete for the same resources, leading to gridlock and delays. Frequent timeouts during database operations can disrupt transactions and create data inconsistencies. High CPU or memory usage on database servers can result in slowdowns or even crashes, further impacting performance. Excessive locking or blocking of transactions can lead to significant delays in data processing, while inefficient or unoptimized queries can strain the database, causing slow response times. Long-running transactions that tie up resources for too long can hold up other processes, creating a cascading effect on performance. High disk read-write latency can severely impact overall database efficiency, and slow database backups or maintenance tasks can affect availability and performance. Poor indexing, leading to full table scans, and fragmented indexes that slow data retrieval are also common culprits of degraded performance. A high number of temporary tables or excessive use of TempDB can overload the database, while increased query plan cache memory usage can lead to performance degradation as the database struggles to manage its resources. Connection pool exhaustion, poor performance during complex join operations, and data replication are few more symptoms of database performance issues. To diagnose these issues, we employ a range of tools and techniques. Starting with monitoring and profiling tools like New Relic, Datadog, or Zabbix provide insights into I/O waits, CPU memory, disk, connection pool, query performance with slow query logs, and potential indexing issues. Examining the execution plans of slow queries gives view of the most resource-intensive steps in the query. By identifying symptoms like slow queries, high I/O wait times, and resource contention, and using the right tools to diagnose and optimize, we can keep your database running smoothly, even under heavy load. Having covered the database, let's now explore the infrastructure layer. Infrastructure performance issues can manifest in various ways. High CPU utilization and insufficient memory allocation will cause applications to slow down or even crashes. Disk I/O bottlenecks are also a significant concern, as slow read or write operations can create processing delays across your entire system. Inconsistent load on servers, often due to incorrect load balancing, can result in some servers being overwhelmed while others remain underutilized, leading to uneven performance. The absence of auto-scaling and auto-healing capabilities can also strain your infrastructure. Lastly, high infrastructure costs can arise from inefficient resource usage and a lack of cost optimization strategies, unnecessarily driving up your expenses. To diagnose infrastructure-level issues, we use a combination of stress testing and monitoring tools. Stress testing is designed to push your system to its limits. When paired with robust monitoring tools, this approach becomes a powerful strategy for uncovering and resolving performance bottlenecks. Server health monitoring, including CPU, memory, and storage, is conducted with tools like Zabbix, Prometheus, New Relic, or Datadog. These tools allow us to monitor resource usage in real time, ensuring that resources are allocated correctly and that unexpected spikes in utilization are promptly addressed. I/O performance monitoring tools such as IOstat and perfmon are essential for tracking disk read or write operations, helping us identify and resolve bottlenecks that could impact performance. Tools like HAProxy, Nginx, and AWS or Azure ELB or NLB help us assess and configure load balancing, ensuring even distribution of traffic across servers. Finally, cost monitoring and optimization are critical for managing infrastructure expenses. Tools like AWS Cost Explorer or Azure Cost Management help us track and optimize infrastructure costs, ensuring efficient resource usage and eliminating unnecessary spending. Let's turn our attention to diagnosing network performance issues within your infrastructure. Network performance symptoms include users experiencing slow response times, dropped connections, or high latency. Reviewing existing network documentation, such as topology diagrams, configurations, and baseline performance metrics, is crucial. Comparing current performance data with historical records can help us identify deviations from normal behavior, giving us a clearer picture of what's going wrong. Analyzing traffic patterns through NetFlow or SFlow can help us identify bandwidth hogs, unusual traffic, or even potential security threats. Ping and traceroute tools are also useful for testing connectivity and latency, helping us pinpoint where delays occur in the network. We verify the correctness of routing tables to avoid routing loops or misconfigurations. Check firewall rules and access control lists to ensure they aren't blocking or throttling traffic unnecessarily. Advanced diagnostic tools provide deeper insights. Wireshark, for example, allows us to capture and analyze network traffic at a granular level, helping to identify anomalies. Network performance monitoring tools like SolarWinds, Nagios, or PRTG give us comprehensive visibility into network performance. We also use command line tools such as IPR for bandwidth testing, Netstat for checking open ports and connections, and TCPDump for capturing packets. By combining these diagnostic approaches with real-time monitoring and historical analysis, we can systematically identify and resolve the root causes of network performance issues, ensuring a more reliable and efficient infrastructure. We recommend usage of comprehensive monitoring tools that can achieve granular level of monitoring, which is essential for real-time diagnosis and proactive performance management. This involves several key components, starting with Integrated Application Performance Monitoring, or APM tool that provides real-time insights, enabling teams to quickly identify and resolve performance bottlenecks. Automated performance alerts help you stay ahead of problems by notifying you the moment something goes wrong, enabling rapid response and minimizing downtime. Incorporating performance testing into your CI or CD pipelines is another crucial aspect. By testing performance at every stage of development, you can catch potential issues early and ensure that your code is optimized before it reaches production. Leveraging AI-driven insights allows you to identify patterns and anomalies that might be missed through manual monitoring. AI can help predict potential performance issues before they become critical, giving you the opportunity to address them proactively. Together, these elements form a comprehensive end-to-end performance monitoring strategy that ensures your system remains robust, responsive, and ready to meet the demands of your users. At Kadel Labs, we've effectively used our performance engineering framework to enhance application performance for several customers through ongoing monitoring and support. We're ready to help you achieve similar results. Contact us to explore how we can optimize your application's performance. Thank you, and we look forward to partnering with you.